Alright guys, do believe I am up and going again. Oh, it's right there. Alright, so I'm wondering if the video and sound's coming through. If it is, just send me a message. Boom. So there's mine right there. There is about a 30-second delay, so it's a little weird doing this. And then before we get started, I just want to kind of say why I'm doing this. Coda's got the right ID. He's taking a nap. So just text back in the chat if you can hear me and see me. Thanks, Tori. He's 14 years old, so yeah, he has his own spot. He always sleeps wherever he wants to sleep. Thanks, Tori. He's 14 years old, so yeah, he has his own spot. He always sleeps wherever he wants to sleep. Perfect. What question do you have? All right, so before we start, I just kind of want to say why I'm actually doing this. I just want to say a few words why I'm actually doing this. I was raised to actually help people whenever I can, and since 2015, I've been making and posting videos of supplemental instruction to my students. While I was researching on how to make these videos more engaging to my students, I learned about free and paid software that online gamers and YouTubers use. This gives me a unique opportunity that I never thought I'd actually have. I have the equipment and software to live stream like a gamer, but I'm not a gamer. And the ability to answer math questions like a high school teacher. I am doing this live stream to help anyone, anywhere on math, on any topic. It's not just my students. Except for stats, it takes too much time and I'm pretty rusty at it. I really don't care if you just simply ask me how to add or subtract fractions or just my opinion about math. I'll answer you. I'll only answer questions related about math and my dog Coda, as a student just asked, who's been my sidekick for the last 14 years. This is me just trying to do what my mom raised me to do, to help people when I can and to give back to society and community. So let's start. Any math questions? So guys, you have to ask me questions. I'm not just going to come up here and just teach. This is just here for me to help anybody, anywhere, with anything. But if you don't have any questions, I don't have anything to do. So day one, the first category for multiplying. Okay, so let me pull that document up here. Resources. Day one, category for multiplying. Tori, of the 4 pages, which one are you looking at? The spiral day 1, spiral day 1B. Oh, wait, I'm in geometry. There we go. Multiply. It's not that one. Not that one. All right, so I'm going to go ahead and do the clarification station day 1, problem 4. I'm going to write it up on the board here. Let's see. So we have x squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x squared plus 4x over x squared minus 4x plus 3. Okay, now I ask you to multiply these and state the domain. So whenever we're doing rational functions, in class I said the way to make your life easier is to factor. We want to factor everything first before we really start doing anything. So I'm going to factor my numerator, my denominator, my numerator, and my denominator. So the x squared plus 3x minus 4, that's actually going to factor to x plus 4 and x minus 1. This gives me my negative 4. 4 times negative 1 is negative 4. And then 4 minus 1 gives me my positive 3. So my top is factored. All right, my bottom factors to x plus 2 times x plus 2. 2 times 2 is 4, and then 2 plus 2 is 4, so we're factored there. So we're going to come over to the other side here. We have 2x squared plus 4x. I have a greatest common factor of 2x. I can take that out, and that's going to give me x plus 2. Once I take the GCF out, and the bottom here, x squared minus 4x plus 3, that's going to factor to x minus 1, x minus 3. Negative 1 times negative 3 is a positive 3, and a negative 1 plus a negative 3 is a negative 4. So now I'm factored. So what I'm going to do right now is I'm going to actually find the domain. I'm going to find the way to find the domain is I'm going to look at my denominator here, and I want to say what numbers cannot equal 0. So in this case, I have 2x plus 2, so I'm not going to write that out. But I have x plus 2 cannot equal 0. I have my x minus 1 cannot equal 0. And my x minus 3 cannot equal 0. From there, we just simply solve them. These are linear equations, so we know, therefore, x cannot equal negative 2, a positive 1, and a positive 3. So this is going to be my restriction on my domain. I'll write the domain at the end of the problem. So now I'm going to come back up here, and I'm going to look. Now that I've got my domain part all taken care of right here, before I do anything else, I'm going to look to simplify. Simplifying makes my life so much simpler. That's why we simplify math, is to make the next step simpler. So I'm going to look up and down, just like reducing a fraction. Look for anything that it's alike. The x plus 4, x minus 1, and I have x plus 2's on the bottom. Nothing's alike, so nothing simplifies. I'm going to look on this side. 2x and x plus 2, and then x minus 1 and x minus 3, nothing up and down simplifies. But when we multiply fractions, this rather it's with numbers or with polynomials like this, we can cancel on the diagonal. So if I look at the x plus 4, x minus 1 in my numerator here, and my x minus 1 and x minus 3 here, if anything matches, they divide out and become the number 1. So my x minus 1 and x minus 1, they go away. So the only thing left on this part is the x plus 4. The only thing left here is the x minus 3. I'm going to look on this diagonal right here, and I see that I have an x plus 2 and an x plus 2. Both of these become a 1. And this really just simply simplifies down to x plus 4 over x plus 2 times 2x over x minus 3. All right, from here, when we multiply fractions, we just multiply straight across. So I'm going to have 2x, x plus 4, and then x plus 2, x minus 3. And then from there, you can do hippity-hoppity distributive property. If you want, you can FOIL the bottom. You can leave it like this. I'm not real picky. I'm more concerned about these steps in here. Now, for the actual domain, to write it, it's going to be the set of all x's such that x is an element of the real numbers, and x cannot equal the numbers we found right here, which is negative 2, 1, and 3. And you're done. Hopefully that helps you out. So let me erase and get ready for the next problem. So I hope that helped you. I hope that answered the question that you had. Keep firing away if you have any other questions. You can tell Coda really cares about math over there. He's just knocked out. All right, so IDC, when you talk about quadrilaterals, day 1, spiral questions, which number? You want to do spiral 1 or spiral 1B? Because there's two different documents there. Spiral 1. Is there a particular question you want me to do, or I do need to say this, guys. If you are accessing this on Schoology, I'm going to go in and kind of fix it, because for some reason some of the points and vertices aren't showing up. Mr. Shotwell shot me over a text this morning saying, hey, there was a problem with the documents that we uploaded. So I'm going to fix that here shortly and upload it. If that's the issue where it's asking questions but you don't see any numbers, that's what's going on right now. But we're figuring this out as we go as well. So. Okay, so you just don't understand how to solve them. So I'm just going to start at number 1. Number 1 is just nothing more than a distance formula. So you're going to need to use the formula, my distance, where it's going to be my x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And of course, we're taking the square root of the whole thing. We did the, I wrote a little too high on that one. We did the distance formula last semester. This is something that we're going to have to use over and over and over again. It comes up in math all the time. So let me write the points here, and I'm going to show you how to find the distance between these 2 points. So we have point M, which is 9, negative 5. And then we have point N, which is negative 11, comma 10. All right. So I'm asking you to find the distance between these 2 points. Well, we have our distance formula right here. It doesn't matter which point you pick to be 1 or 2, but you have to stay consistent. So in this case, I'm going to pick this. I'm going to pick M as 1. So this is x sub 1, y sub 1. Coda's got an itch over there. He's bored. And then this is going to be x sub 2 and y sub 2. From there, I'm just going to plug them into my formula. So I'm going to have my distance equals, let's see, I'm going to have negative 11 minus 9 squared plus 10 minus a negative 5 squared, and then we're going to take the square root of this whole thing. Well, from here, it's just working your elbows. It's just arithmetic. Negative 11 minus 9 is going to give me a negative 20. I'm going to square that. And then 10 minus a negative 5 is going to give me 15, and I'm going to square that. And of course, we have to take the square root of the whole thing. All right, so negative 20 squared is 400. 15 squared is 225. We're going to take the square root, and then the square root of 625. I'm drawing a blank right now. 625, square root of 625 is just 25. So my distance between points M and N is just 25 units, whatever the units are. It could be inches, centimeters, doesn't really matter. So that's actually how you work number 1, all distance formulas. Once you know the distance formula, just pick a point to be 1, pick a point to be 2, and then just stay consistent. Plug them in, and then just work your elbows and do the arithmetic. Use a calculator if you have to. I had to use a calculator because I forgot the square root of 625 off the top of my head. Don't miss a problem because of pride trying to do it in your head. So I'm going to jump in. Let's see, number 2 is find the distance between 2 coordinates, which is the same thing. That's where the app. On number 3, you have to use your distance formula 3 times and then add up the distances because it asks for a perimeter. And then 4 is a midpoint question, so I'm going to show you how to do a midpoint question. I hope this helps you answer. Hope this answers your question. Coda, what you doing? Where are you going? He just left me. What a bum. Okay. Come here. Come on. Coach, come on. Come here. Come here. Come on. Come here. Fine. Go lay down. Just go lay down then. All right, let's do number 4. It's a midpoint formula. So we need to know our formula. So our midpoint formula is nothing more than the average of my x's and my y's, which is x sub 2 plus x sub 1 divided by 2 and y sub 2 plus y sub 1 divided by 2. All right, so it asked me for, use the midpoint formula to find the midpoint between the coordinates. They give me the coordinates of -7, 3. And then another coordinate of 11, -5. Once again, just like with the distance formula, it does not matter which one's 1 and which one's 2. So I'm going to just label this as x sub 1, y sub 1, x sub 2, y sub 2. Plug them into my formula, spit out an answer. So here we go. I have 11 plus a -7 divided by 2, comma, this is a point, -5 plus 3 divided by 2. Well, 11 minus 7 is 4. 4 divided by 2 is 2. -5 plus 3 is -2. -2 divided by 2 is -1. And right there is my midpoint. So this is my midpoint. That is my midpoint. Done. So that pretty much covers the spiral station day 1. It's either a distance formula or a midpoint formula. Not terribly bad. The key is use your points, label them as a 1, label them as a 1 and 2, plug them into your formula, and you're good. All right, let me jump over to Algebra 2 here. Good, buddy? Day 2, question 2. Oh, day 2. Tori. Okay, so on this problem, so what I'm asking you to do here, I have 4 over x plus x. And I want you to add these and tell me the domain. So the very first thing I'm going to do is I'm going to write this as a fraction over a fraction. So I'm just going to rewrite this. This is really just the same thing as, oh, hold on, he decided he wanted to get down. There you go. All right. So this is really the same thing as 4x plus x over 1. Coda, what are you doing? Just go lay down somewhere. Mama's not here. My camera may bump here in a second. All right. So what I need to do is let's look for what values can x cannot equal. Basically, what numbers are going to make my denominator 0. In this case, it's pretty straightforward. My x cannot equal 0 whatsoever. That's simply because I have a 0 in my denominator right here, and it just doesn't work. All right, now to add these, when we add fractions, we have to have a common denominator. So we have 4 over x plus x over 1. We can multiply my denominators here, and I'm going to do x times 1 is just going to give me an x. That's my new denominator. Now I want to multiply up here, and pay attention to the way the arrow is actually pointing. 1 times 4, and that's going to go first. 4, I'm going to bring my operator down, plus. I want to multiply up this way, and that is x times x, which is just simply x squared. So then my solution to this whole thing, is simply going to be x squared plus 4 divided by x, and then my domain is going to be the set of all x's such that x is an element of the real numbers and x cannot equal 0. Done. Pretty straightforward. Could have literally just booped the Kodacam. All right, I hope that answered the question. What else, guys? Hey guys, tell all your friends that I'm on here doing this. This is just simply to try to get y'all through. It's just I'm bored at home, so this gives me something to do. And then, to be honest with you, I know you guys kind of struggle with this stuff. So if I enjoy doing this and you're struggling with it, this is nothing that the school's telling me to do or anything like that. It's just, why not? Trying times. Desperate times, desperate measures. So yeah, tell your friends, family members, anybody that needs help with any math. It doesn't have to be my student. I don't care. Only issue is if they come on here and asking me like statistics questions. I'm really rusty at statistics, so it takes a little bit of. I'm just not going to answer statistics questions because one, they take too long to explain. And two, I'm really rusty at it. I can do probably most of differential calculus off the top of my head. Interval calculus, little different. I'll have to actually look into it, probably post back to you on a comment. But yeah, it's not just for my students at all. Well, I'm gonna be right back. I'm gonna go get my Rubik's Cube to play with unless somebody asks me another question. Stay. Dude, I told you to stay. I'm so slow with this now. I don't ever get to play with it. I guess that's all the questions I have. So guys, a couple more minutes, and if you don't have any questions for me, I'm just simply going to take down the stream. Maybe not for a whole hour, but just take it down. I'll pop back up about 5 o'clock if you have any other questions that pop up, or if you have any friends or anybody else that have questions. Just gives me something to do. Instead of just sitting here, I can only watch so much TV, read so much books, clean so much. Oh, here comes Coda. I think my wife is back from helping her mom. Careful there, buddy. Yeah, I'm talking to you. Careful. All right, so it's okay if you're struggling with it. You can just skip that part of it if you don't understand it. It's really hard with math. There's other videos out there. Maybe Khan Academy can help you as well. I'm going to work another one. Let me work another one, and maybe that would help with the explanation off that clarification statement. Maybe one a little bit more difficult. I want to just actually do number one and see if that actually helps you. All right, so I've got x plus 3 over x squared minus 2x minus 8 plus x minus 5 over x squared minus 12x plus 32. Okay, so I'm asking you to add these, and then I'm going to ask you to find the domain. So the first thing I need to do, rational functions on anything, is factor everything. So my top here is already factored. So I have my x plus 3. My bottom, let's see, what combination of negative 8 gives me a 4 is going to give me 2. Gives me a 2 is a 2 and a 4. So I want to have x minus 4, x plus 2. Negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. So plus my x minus 5 is already done. What combinations of 32 gives me a negative 12? Well, that's going to give me a negative 6 and a negative 6. So that's x minus 6 and... No, 6 times 6 is not 32, James. Wow. 6 times 6 is not 32. Oops. 8 and 4. So that should give me, yeah, x minus 4, x minus 8. Negative 4, negative 8 gives me a positive 32, and negative 4, negative 8 gives me a negative 12. There we go, I'm factored. All right, so once I get it fully factored, that's the very first key, is factor. Once everything's fully factored, I'm going to look and see what domain restrictions I have. So I can see from here x cannot equal 4 because that would make this a 0. Cannot be a negative 2 because that'd be a 0. 4 because that'd make that a 0, and an 8. So I'm just going to make a side note here. X cannot equal 4, negative 2, and 8. So those three numbers, no matter what, even if I do all the math and I get x equaling one of these, it can't be an answer because it would make a 0 in the denominator. All right, so what I need to do here is when we add and subtract fractions, we must have a common denominator. So I have an x minus 4 and an x plus 2 as one denominator. My other denominator is x minus 4 and x minus 8. So what I'm actually going to do is I'm going to look and say, hey, look at these denominators and say, what's it missing? So I have an x minus 4 and an x plus 2 here, x minus 4 and x minus 8. Well, I see that this x minus 4 is in both of them, so I don't have to do anything with that x minus 4. But this x plus 2 is missing this denominator. So what I'm going to do is I'm going to multiply it by the number 1, but it's going to be a fancy one. I'm going to multiply this by x plus 2 divided by x plus 2. So whatever this denominator is missing, I'm going to just set up a number 1 and multiply it by that. On this one here, I'm going to look and say, okay, you know what? It's missing this x minus 8. So I want to multiply this by x minus 8 divided by x minus 8. Now what you have to remember in math is that you're only allowed to add 0 or multiply by 1 where it doesn't change the equation. So x minus 8 divided by x minus 8 is the number 1. So I actually didn't change this first term. I'm just making it look different. And the x plus 2 divided by x plus 2 is just the number 1. Once again, didn't change this term, just making it look different. But now if you notice, when I multiply, I'm going to have a common denominator. So I multiply straight across on both of these. And I'm going to get x minus 8 times x plus 3 times plus x minus 5 x plus 2. And that's all going to be over the exact same denominator. That's what we did, is we created a common denominator, my x minus 8, x minus 4, and x plus 2. So I have my x minus 8, x minus 4, and x plus 2. All right, now I have a common denominator. All I need to do is clean up my top. Don't mess with the bottom. I don't care. This is going to be a cubic. I don't really care about that, but I do want you to clean up the top. So we'll have to do FOIL. With the FOIL itself, I'm just going to do it real quick here. X and x, this gives me x squared. Let's see, minus 5x minus 24 plus x squared minus 3x minus 10 all over my x minus 8, x minus 4, and x plus 2. All right, from there we just simply combine like terms, and I'm going to have 2x squared. That takes care of these. A negative 5x and a negative 3x is a negative 8x. This and this is gone. And this gives me a negative 34 all over my denominator, which is the x minus 8. And I know you can't see this. I'm just rewriting the denominator. And that's my answer. So really, the key step is right here, where you're going to have to multiply by the number 1. You're going to have to look and see what this denominator is missing, and then set that up as a number 1 to multiply straight across to create a common denominator. Not really terribly bad. I know it looks bad. It's not really terribly bad. It's just fractions. No big deal. Now we do need to write the domain of this. So the domain of this is going to be the set of all x's such that x is an element of the real numbers and x cannot equal. Here's these numbers. I'm going to put them in negative 2, 4, and 8, and I'm done. There's the domain. There's my answer of adding these fractions. Hopefully this helps out. I hope that helped you. Anybody else have any other questions? Let's see, where's my red blue? Quadrilaterals, clarification station 2. Question 4, please. IDC, which day? Is it day 1? All right, cool. So guys, people are asking, do the stuff. I'm going to individually respond to any emails that y'all send me. I'm not going to answer those on the stream. I do have some people asking me some questions that I'm just not going to address on the stream. I will send you out individual emails on that. So let me just dive into number 2. There's actually, it's A through G. So the first thing I do is you have a trapezoid. I give you a diagram of a trapezoid that looks like this. And this is A, B, C, D, E, F. Okay, so that's the diagram that you have. And the first question I ask is trapezoid ABCD is also a quadrilateral, and explain? Pretty straightforward. The definition of a quadrilateral is it has 4 straight edges. Does this figure A, B, C, D have 4 straight edges? If the answer is yes, it's a quadrilateral. If the answer is no, it's not a quadrilateral. And that's your explanation is it's a quadrilateral because it has 4 edges. Okay, let's see. So A is true. You just simply say because it has 4 sides, it's a quadrilateral. Easy enough. B, I actually say AD and BC are called what? No, wait, AB and CD are called blank of the trapezoid. So AB and CD are called what? Well, those are the legs of this trapezoid. And then I asked on C, AD and BC are called what? These are called the bases of the trapezoid. And also in the diagram, I tell you that all 3 of these are parallel. All right. On D, it says EF right here. Well, that's called a mid-segment. These are just the basic breakdowns of what this trapezoid actually is. Then E, it says the measure of angle A plus the measure of angle B equals what? Well, these are 2 parallel lines. This is actually a transversal cutting 2 parallel lines. That's something we did last semester. We know the same side interior angles of a transversal cut by 2 parallel lines cut by transversal, that the same side interior angles are supplementary. So that means if I add these 2 angles up, supplementary means they're going to equal 180 degrees. And then basically says F is, what is the slope of AD and BC? Now, it says the slope of AD and BC are the blank. Oh, I should have worded that better. Basically, what I'm looking for is AD and BC. These are parallel. Easy enough. The bases of a trapezoid are always going to be parallel. Legs are not going to be parallel. Bases are going to be parallel. Simple as that. And then last but not least, G is, I give you a formula. The formula is 1/2 of AB plus CD. This is nothing more than EF, this line right here. So if I need to know the length of this line, I know I just take this line plus this line, divide it by 2. That's my mid-segment. It's the average of the 2 lengths of those 2 segments. So that's number 2. Not much to it. All right, so what other questions? I'm tired. Let's see. Which class? I think Coda is right with you with your name, though, because he's tired too. He's just knocked out over there. Math just puts him to sleep. He loves it so much. All right, so day 2, question 2, clarification, geometry. Oh, finally we get to do some real math, or somewhat real math. Okay, so let's dive into this. I give you a trapezoid, and I tell you it's an isosceles trapezoid. So let me draw a almost isosceles trapezoid here. These lines are parallel. These legs are congruent. I then tell you that this is 5 minus 4x. And I tell you that this is x plus 20. I give you this angle right here as 7x plus 13. That's a 13, not a B, degrees. And I tell you up here, this is 8x plus 17 degrees. Then I say find CD. So I guess I need to put the points here. A, B, C, D. Okay, so I'm really asking you to find this length right here. Now, because this is an isosceles trapezoid, we know that this leg and this leg is congruent. Whenever you're doing math and in geometry, we've done this a ton in class, whenever we hear the word congruent, we're going to think of an algebra equation with the equal sign. So I know that I can actually set these legs equal to each other. 5 minus 4x equals x plus 20. From here, I can just solve for x. So I'm going to add 4x to both sides. Now I have 5 equals 5x plus 20. Subtract 20 from both sides. I have negative 15 equals 5x. Divide 5 on both sides. X equals negative 3. Okay, so now we have what x is. But that hasn't answered the question yet. It says find CD. CD. Well, CD is x plus 20. So CD is going to be, I'm going to take this x that I just found, negative 3. I'm going to add 20 to it. And I'm going to get 17, and there's my answer for A. Not terribly bad. Key thing is, anytime in math and in geometry, when they say things are congruent, I take advantage of that by setting up algebra equations. Congruent is going to lead to an algebra equation with equal sign. Use your algebra to then turn around, your answer for your algebra to turn around and plug it back in to answer the geometry question. So there's A. Let's do B. B says, find the measure of angle A. So I'm looking for this measure of the angle. It's really the same thing here, but instead of finding a length, I'm finding the rotation of the angle. All right, so here, because these are parallel lines and this is being cut by a transversal, these are same side interior angles, or if you remember the properties of an isosceles triangle, any consecutive angles are supplementary, I believe, off the top of my head. But these two are going to add up to be 180 degrees. All right, so here we go. All I'm going to do is simply do 7x plus 13 plus 8x plus 17. I want to put these in parentheses, and I want to decide if I need the parentheses or not, and that's going to equal 180. I'll put the degree symbol at the end. Now, the reason why I put the parentheses here, because if this is a minus, I'd have to distribute it. But because it's not a minus, there's no need for the parentheses, so I can just drop it, and I have 7x plus 13 plus 8x plus 17 equals 180. Combine like terms, 7 and 8 gives me 15x. Plus, let's see, 13 and 17 gives me 30, equals 180. I'm going to subtract 30 from both sides. I have 15x equals 150, divide by 15, x equals 10. Now we're not done at that point because the question originally asked, find the measure of angle A. The measure of angle A is 7x plus 13. So the measure of angle A is going to be 7 times my x, which is 10, plus 13. Plug it in, 7 times 10, 70, plus 13 gives me 83 degrees. So this right here is 83 degrees. Piece of cake. Guys, I know you're familiar with problems like this. We do these all the time in class. We're going to use geometry to set up an algebra problem, solve the algebra problem, use the algebra answer to answer the geometry question. I hope that helped you out. Good over there, buddy? It's not comfortable. Any other questions, guys? We've got about 7 minutes here. Enough time for at least one more question. And done. Guys, once again, this is not just for my students. It really isn't. Tell your friends, family members, anybody that's confined to their house is trying to do math. I'm going to be here. I'm bored. I can only do so much before I go stir crazy. So this is at least one way that I can help everybody out. And Coda doesn't mind either. Gives him his napping spot over there. So. I'm tired. Did that help you out? All right, guys. I'm going to go ahead and end the stream. I'm going to pop back up about 5 o'clock. I've got some work to do here, responding to emails and everything else. And I've already responded to quite a few. I'm also going to send out some messages. So feel free, make sure you use the learning management system that we use. Send me messages directly, and I'll get back with you on that. Once again, I'm just saying, I'm just doing this just because I'm bored and because I like showing math. It's just fun.